Hello everyone, welcome to engineering drawing tutorials. So in this video again I would like to explain how to analyze the orthographic views and how to draw the orthographic views, which means front view, top view and side view. So this is an isometric view for a product. Okay, so for this product we need to draw what are the orthographic views, means what is the front view, what is the top view, what is the side view we need to draw. Here we are going to draw front view, top view and the right side view we are going to draw, which will be on left side to the drawing sheet. So slowly one by one we'll try to analyze the front view, top view and right side view. So first I would like to analyze the front view, which already given as x direction for this isometric view. So in this direction, so what will be the front view, means here whatever the surface which is normal to the front view, that will be the front view only. So already I have told you so many times in the previous videos. So now, so already I have given the lettering, that is the F and F. F and F means on which surface I have represented F, that will give you the front view for the object. Okay. So here I have given the F two times only. So that means here these two surfaces only we can see in the front view. Why? Because these two surfaces only normal to our front view. Okay. So this first surface is in a shape of L and this is in a shape of the rectangle. So when you join these two, we can see another rectangle. So the front view will be like a rectangle with a particular shape inside of it. So first we need to draw a rectangle which we can see in the front view. So for that we have to know what is the base length is given. This is the base length where I am moving my cursor. So this length, how can we find out, means already we know up to this particular distance 15 mm. Okay, and how to know the remaining distance, means here the width is given for this particular step, and again remaining width is given up to the end, okay, up to the edge of the given object. So 10 plus 10 is 20 and 20 plus 15 total will be 35. So equal to the 35 mm length, we need to draw a line first for the front view. So take the reference of xy reference line. This is an xy reference line. So above it select any particular distance. Okay, so above this xy reference line try to draw a line with an equal distance of 35 according to the analysis we have done here for drawing the front view. So represent with 35 mm. So next we need to analyze the top view, sorry, height of the front view. Okay, the height is already directly we can see on the figure which is given as the 40. So height of the total height of the object is 40 mm only. So now draw a line equal to the length of 40 mm. So again at another end, so from this point draw a line which should be equal to again 40 mm and complete this rectangle. Okay, by closing the rectangle here. So 40 by 35. So in this again in front view we can see this edge clearly. Okay, now so rather than this total edge in the rectangle, so there is a step is there. Okay, now so for this particular step we can see the edges in the front view. So we need to know what is the height of this edge, what is the width of this edge. Okay, the width of this edge is given as 15. The height of this edge will be equal to, total height is 40 and this height where the step has started is 20. So 40 minus 20 will give you remaining height of the edge here. So for that again this edge is at a distance of 10 plus 10, 20. Okay, equal to this distance is only the edge will be there. So from this distance the edge will start. So first to try to locate this edge, top edge on the top of the rectangle we got in the front view, that is 20 mm. So from this 20 mm point draw a line equal to the 20 mm. Again in the front view we can see this edge also in a horizontal direction as a horizontal line which is at a height of 20. Again represent 20 mm and draw the line until it intersects the first drawn line. So like this we can see in the front view, and at the same time there are certain hidden edges are there in this figure. In the front view we cannot see, but we need to represent on the front view. Okay, so what are those edges, means one is this one, this corner point. Observe the cursor where I am placing my cursor. So here at the back side of this surface there is an edge with a particular height. Okay, na? So that is at a distance of 10 from the last edge of the surface. That means from the rectangle here, last side of the rectangle, at a distance of 10 mm, there is a particular edge up to particular height. Okay na? So first try to draw a line with a distance of 10 mm. So at a distance of 10 mm only the edge is taking place. So from this side locate that. Oh sorry, before that I'm drawing this edge. So other than this edge, again there is another edge below the surface here. So at the back of the surface again there is another edge at the bottom of the object, which is at a height of 10. Okay na? So first on the diagram I would like to represent. Next we go for drawing this edge from the top of the surface. So it which is, and this bottom edge is also at a distance of 10 mm, that means at a height of 10 mm. So first to locate the point equal to the distance of 10 mm on the first front view. Okay, then from this point draw a hidden line. Why hidden line means which we cannot see but the edge is there. And next already we have analyzed this edge here, okay, from the top surface of the object which is at a distance of 10. So again from the last side of this left side of the rectangle at a distance of 10 mm, we cannot see the edge but we should represent with the hidden lines until we intersect the first hidden line we draw. Okay, so this is the final front view we can see for this object. Okay, including all the edges which are visible and which are invisible. Okay now, so from this front view we can project the top view by drawing the construction lines from each and every side or edges of the front view. Draw the projection lines or construction lines like this. Okay, so after this I want to analyze the shape again. So in the top view, okay, in the top view whatever the T letter I have represented, those surfaces we can see. Okay, so when again you join all the surfaces we can see a particular shape. Okay now, so initially assume in the top view. Okay, so in the top view assume this edge as a straight line. So we can see this edge as a straight line, so which is equal to the distance of again 15 plus 25. That means already we have drawn 35 mm, so in between that 35 mm length only we can get the top view. So for that draw a line again at a distance with which is equal to the 35 mm. So in between the two construction and the construction lines draw a line. Okay, next I want to represent this edge which is equal to 10 mm. Okay, this edge I want to represent which will be left side on the drawing sheet. So because it is also in the left side in the drawing sheet. Okay, so from this point draw a line equal to the distance of 10 mm. Okay now, so after 10 mm the again the shape is changing according to the step provided. Okay now, so this step again equal to a distance of 10 mm. So again this line we need to represent parallel to this edge. Okay, edge of the top view or top surface. So parallel to this again draw a line. Already we have represented the construction line. So in between these two construction line we can draw a line which will be equal to automatically 10 mm only. So now again we need to I want to represent this edge. Okay, now after drawing these two lines I want to represent this edge which is equal to the length of 30. So from this point again draw a line which is equal to the distance of 30 mm. So after that again another extruded step is there which is same as the 10 mm only. So again from this point draw a line to the left side in a horizontal. Okay now, so in between the two construction lines, and similarly this edge we need to represent which is again equal to the length of 10 mm. So 10 mm equal to that draw a line, and again to complete this one, so up to which line we need to draw total. Why? Because total means here this total edge we can see as a straight line in the top view. So when you see this object, however we are seeing this edge as a continuous straight line, so this last edge is also we can see as a straight line. So after drawing the straight line, join these two on the construction line. Sorry, before that I want to represent this line. Okay, this edge also we can see this edge, this one and this one and this one we can see. So for drawing this T-shaped edge, first I want to locate this line. Okay, this edge line which is equal to the length of 20. So for that I have drawn the line which is equal to the length of 20, and similarly from the top edge also we can see an edge which is again equal length will be there. So that is also equal to the 20 mm. So from the top on the construction line draw a line, okay, which is equal to again 20 mm. So from these two end points we got draw two lines so that this view can be obtained. Then join the total, so we can see the top view exactly whatever we can see. And similarly here also there will be hidden lines in the top view. So this corner, whatever this corner edge is there above and below, these edges will be hidden in the top view, so which will be passing from this edge only, this top edge. So that means from these two lines, wherever I am showing my cursor, at a distance of 10, at a distance of 10 from the bottom, so from these two lines we have to represent the dashed lines. Those are the hidden lines. Why? Because there is a edge which cannot be visible in the top view, and as well as in the front view also we cannot see. So that's why we need to represent with hidden lines. So this is the final top view. So next we go for right side view. For that, draw a line at a particular distance from the two projections we have drawn with an angle of 45 degrees. So after drawing this line, so draw the projection lines like this. Okay now, so from each and every edge we need to draw the projection lines until they intersect the line which is drawn at an angle of 45 degrees. So from these intersecting points, again draw the vertical lines for getting the final right side view. So in this I want to draw first again projection lines from the front view also. Okay, drawing the projection lines from top view, drawing the projection lines from front view, we will be getting certain intersecting points. So by using these intersecting points directly we can draw the right side view. So assume here, again analyze the right side view. So in right side view we can see this surface, okay, in a shape of T or an edge connected to the U shape like this. Okay, and similarly we can see this surface and this surface. Okay, so totally it will be like a rectangle. Again in that rectangle we can see certain edges. Okay, how can we draw that edges? Means first I would like to show you the two last edges. Okay now, so these two last edges will be continuously visible. Okay, similarly this top edge is also continuously visible as a straight line. Okay, so now I would like to draw this edge wherever I am showing my cursor here, so which is equal to the length of 10. So we need to draw here, okay, 10, and similarly draw another edge which is again at a height of 10, so already represented here 10 line. So now again join this until it will intersect this construction line, which means this edge point to this edge point will be showing. So similarly draw a line vertically, draw a line horizontally. Okay, some shape will be completed. Next I would like to show these two lines up to these two construction lines. Okay, these two lines represents these two edges of the object, and similarly from these 2 points draw the two vertical lines. So automatically the required right side view will be completed. Okay, so like this we can draw the front view, top view for a given object which is given in isometric view. So those are only orthographic views. Okay, so this is little bit complicated figure, so carefully we need to analyze what are the surfaces we can see in the front view, top view and right side view. So based upon that, by drawing the front view we have to project the top view and left side view. Sorry, here right side view. So right side view means we'll be getting on left side, left side view means we'll be getting on right side. So please remember that. So I hope you understand this explanation for drawing the orthographic views. Okay, and once again thanks for watching my video. Thank you.